Okay. All right. So in today's class, let's talk about, let's build on the previous concepts. We were able to discuss the basics of electrolysis. Let me go over what we discussed quickly, right? So first we established what redox basically means. A redox reaction is one जिसमें reduction and oxidation दोनों हो. Reduction and oxidation is what make up the word redox. Oil rig was a mnemonic that helps you remember कि oxidation और reduction क्या है. Oxidation is the loss of electron and reduction is the gain of electron. ठीक है, we did certain examples of writing half equations जिसमें for example bromine, the bromide is negative, it has an excess negative charge, it needs to lose this negative charge in order to gain stability, and so hence it loses electrons. However, if we look at zinc, this is a positive cation, this is a cation, and it has more number of protons than electrons. इसको electrons चाहिए in order to be neutral, in order for its number of protons to be equal to the number of electrons. तो हम इसमें 2 electrons add करते हैं because इस पे positive B2 charge है and it forms zinc neutral atom. ठीक है, we established some rules for writing half equations. Firstly, we wrote the starting and ending form of the element only. ठीक है, उसके बाद हम उसके नंबर ऑफ एटम्स को बैलेंस करते थे. इन दिस स्टेप वी इग्नोर द चार्जेस, वी डिड नॉट केयर वन बिट के चार्ज -1 है या -100 है या -1 बिलियन गजिलियन जो भी है, राइट. वी जस्ट बैलेंस द नंबर ऑफ पार्टिकल्स. ठीक है, और आखिरी में वी बैलेंस द नंबर ऑफ चार्जेस बाय एडिंग इलेक्ट्रॉन्स टू वन साइड. अगर वो A9 है, उसने इलेक्ट्रॉन्स लूज करने हैं, तो द इलेक्ट्रॉन्स विल बी ऑन द राइट साइड, एंड इफ इट्स अ पॉजिटिव आयन देन द इलेक्ट्रॉन्स हैज़ टू बी ऑन द लेफ्ट साइड सो दैट द पॉजिटिव आयन gains the electrons and gains stability, goes towards neutrality, discharges itself, right? Okay, so and we also discussed what electrolysis was at its core. It is the decomposition or the breakdown of an ionic compound through the passage of electric current or through the passage of electricity. Lysis means breakdown, electro means through the use of electricity. Okay, and this ionic compound must be in liquid form. It has to be in molten or aqueous form. It has to be in molten or aqueous form, right? And what we discussed after that was what an electrolytic cell was, what it looked like, because it is a very basic structure that you are expected to know, right? Electrolytic cell is composed of a battery. This is the symbol of a battery. It has a positive and a negative terminal. This is something you should be able to identify. आपको पता होने की ज़रूरत है. This is something which you do in electricity वाला chapter of physics as well. So this is something that will come in handy there as well. अच्छा, the cathodes, the electrodes that we connect to it, they get the respective charges. The positive one gets the positive charge, and the one that's connected to the negative terminal of the battery gets a negative charge. They are called the anode and cathode respectively. We came up with a mnemonic saying कि cathode पे reduction होती है, anode पे oxidation होती है. Electrons are rod-like structures which conduct electricity because इसके अंदर से electrons flow करते हैं, charges flow करते हैं, and therefore they conduct electricity. And the electrodes are made up of usually from metals or graphite. Why? Because why metals and why graphite? Because they can conduct electricity, right? हमें कोई ऐसी चीज़ चाहिए जो electricity conduct कर सके, क्योंकि we need electrons to pass through them, right? And we need them to conduct electricity. Reduction at cathode and anode पे oxidation होगी. These are mnemonics to remember them. These figures will make it way easier for you to remember them, right? Okay, so the electrolyte is something the molten or aqueous solution जो कि यहाँ पड़ा होता है, right? If you see this is the electrolyte, ठीक है, and the electrolyte has ions, और वो ions go to the respective anode या cathode, and there they undergo reduction or oxidation. If it's a cation, it will go to the cathode and it will undergo reduction. If it's an A9, it will go to the anode and it will undergo oxidation. मकसद reduction और oxidation का यही होगा कि उस पर जो charge है, either it's positive or either it's negative, it is discharge और इस पर एक neutral charge 0 का आ जाए, right? And 0 का charge means number of protons would be equal to the number of electrons. ठीक है, that is how it achieves neutrality, how it discharges itself, or what you can say how it becomes neutral. ठीक है, let's talk more about what electrolysis is at its core. Okay, this was a quick recap. We did यहाँ तक क्या scene है, the movement of ions in electrolytes. ठीक है, let's talk about this. Describe the transfer of charge during electrolysis to include the movement of electrons in the external circuit. ये पूरा हम सीखेंगे based on these examples. ये बहुत specific examples हैं, बहुत specific cases हैं जो कि आपके course outline में हैं. Molten lead bromide का case, and we'll use this example to discuss okay, molten compounds, how do they undergo electrolysis, right? Here we'll talk about concentrated aqueous compounds, and then we'll talk about dilute aqueous compounds, because sulfuric acid is also aqueous in nature. इन तीनों को हमने डिस्कस करना है, and how do we decide कि कैथोड पे कौन सा कीटाइन जाएगा, एनोड पे कौन सा एनाइन जाएगा. दैट इज समथिंग दैट इज एक्सट्रीमली इम्पॉर्टेंट. ठीक है, ओके. So let's build on the previous concepts and see where it goes. Okay. All right. So. Okay. Let's talk about electrolysis of molten lead bromide as the syllabus content says. Okay. Let's talk about it. Electrolysis of molten lead bromide. What do we mean by molten? As we discussed in the previous class, molten means जैसे आप आइस को मेल्ट कर देते हैं and it converts into water. Molten essentially means something that's heated at such a high temperature that उसके जो particles के बीच में attractive forces हैं, they are overcome and the solid has converted into a liquid, right? Your chocolate melts अगर उसे गर्मी में रखें, right? That is also sort of an example of how it has become molten. ठीक है. Electrolysis of molten lead to bromide, this 2 again represents the charge on lead because lead is a transition metal. इस पे charge fix नहीं है. We wouldn't know ये कौन से charge वाला lead है unless we don't show it by the Roman number after it. तो 2 means इस पे 2 plus का charge होगा, right? And why plus? Because it's a metal and metals form always ketynes. ठीक है. I hope you remember this very basic rule. अच्छा, with graphite electrodes, ठीक है, we'll talk about graphite electrodes, ठीक है, because graphite, again, they are inert, they have high electrical conductivity, and we'll discuss the reason why we use graphite electrodes. ठीक है, okay. So let me draw. Okay. Let me draw this circuit. ठीक है. This is our battery. ठीक है, इसका negative terminal है, इसका positive terminal है, right? And this is an electrode connected to the positive terminal of the battery. We have another electrode connected to the negative terminal of the battery, right? And we have charges on these electrodes. The one with the positive terminal will have a positive charge, और negative है उस पे एक negative charge आ जाएगा, right? And what will we do now? What will we do now is कि we'll have a container, right? Okay, this is a pretty ugly sort of container. Let's draw a more neat sort of container. Okay, this is a container, right? This is a container, and what we're going to do here is we'll have an electrolyte. Okay, this is the very basic electrolytic cell. You do know कि ये graphite electrodes and these are wires. This is your battery and this is your electrolyte. ठीक है. Okay, so we have molten lead bromide as an electrolyte, right? तो electrolyte में हमेशा we discussed कि it's either molten or it's aqueous. In this case, this is a molten substance, right? अब molten substances में भी as we discussed earlier in the previous class कि molten lead bromide में भी lead ions और bromine ions होंगे, right? Bromide ions as we call them. Only those ions will be present because these ions essentially have charges and these charges move to conduct electricity, or right? So that is what essentially happens. ठीक है. Okay, so इसके अंदर we'll have lead के ions and we'll have bromide ions, right? We'll have bromide ions and we'll have lead के ions. We'll have lots and lots of these ions. ठीक है. We won't have any other sort of ions because the only compound जो कि is part of the electrolyte in its molten state is lead bromide. ठीक है. तो इसके अंदर we don't have water, so we don't have to worry about H plus and hydroxide ions. We only have to worry about the lead ions and the bromide ions. ठीक है. Okay, so what essentially happens is okay, now this is the negative electrode. This is the negative electrode and this is called the cathode. As I showed you earlier. This is the cathode. अच्छा, cathode पे हमेशा ketine ने जाना होता है, right? So which of these is the ketine? The ketine is the positively charged one, right? So lead is the ketine. Lead ion is the ketine. So the lead ion is what's gonna go to the cathode, right? And this is the anode. तो anode पे anion जाएगा. So the bromide ion is going to go here, right? Okay, now let's write half equations for each of these processes, right? Let's start off with the anode. Anode pe hamesha oxidation hogi, and we can see that because we have a negative ion that's going, is pe excess negative charge hai. In order for it to become stable, in order for it to discharge, ये negative charge अगर इससे अपने आप से दूर फेंकना तो इसको electrons lose करने पड़ेंगे. And since electrons lose होंगे, this is loss of electrons, this is loss of electrons. So oxidation was loss of electrons. Oxidation is loss. Oil rig se yaad rakhein, oxidation is loss. Okay, so let's write that. Okay, anode pe what happens at the anode is, okay, let's follow the rules. The initial and final form of the element. The initial form is bromide ion. The final form is gonna become bromine, and bromine is a diatomic molecule. It exists as a diatomic molecule. तो हम bromine के आगे इसके subscript में 2 लिखेंगे, right? Okay, step number 2, let's balance the number of atoms. Let's ignore this charge. We have 2 atoms here, so we must have 2 particles here as well. तो उसके coefficient में we write 2. Now let's balance the charges. We have -1 charge on 1 bromine, and we have 2 such bromines. So 2 into -1, it must be -2 ka overall charge on the left side. So on the right side we also need -2 ka charge. So how would we have -2 ka charge? We'll add 2 electrons. Why? Because 1 electron has -1 ka charge and 2 would have -2 ka charge. Hence this is the final equation of the oxidation that happens at the anode. Okay, right. Let's talk about the cathode for a bit. Let's talk about the cathode. Acha, what happens at the cathode? On the cathode we'll have the cation. The cation is lead 2+ wala ion. So let's write its initial, right, and final form. Do you think we'll have a Pb2 here? No, we won't. Yes, exactly. All metals exist as monoatomic atoms. They don't exist as molecules. Okay, let's balance the number of atoms. We have 1 atom here, 1 particle here, and we have 1 particle exactly here. We have the number of particles balanced. हमें इस charge को फिलहाल ignore करना. The number of particles, 1 on the left side and 1 on the right side. Let's go to step number 3. Let's balance the charges. This has a +2 charge. How would we balance a +2 charge? Does this need to gain electrons or lose electrons in order to discharge itself? Because इस पे एक +2 charge है, that means कि इसको 2 और electrons चाहिए कि इसका 2 positive ख़त्म हो जाए, right? +2 -2 would make a charge of 0, and that is neutrality that we're chasing. तो इसके अंदर we want कि ये electrons gain करे. If we want कि electrons gain करे तो we will add electrons to the right side, and hence you see इसमें electrons gain हो रहे हैं. You know, gain of electrons is reduction, and reductions happen at the cathode, red cat, and this is loss of electrons. Loss of electrons is oxidation. Oxidation happens at the anode. Hence proven कि ये processes यहाँ carry out हो रहे हैं. Okay, now at its core, what's actually happening is कि bromine, the bromide ion goes to the anode, and it loses electron, right? You see कि electrons lose कर रहा है, ये electrons lose कर रहा है, and what happens is कि जो electrons होते हैं, these electrons get stuck to the surface of the electrode. ठीक है, we'll have these electrons here, right? For example, अगर एक bromide ion है, that will lose 1 electron, right? So this electron is going to stick to the surface of the electrode, and what's going to happen is कि यही electron is going to travel. It's going to travel through the wires and through the battery to this electrode, right? It will go to the cathode. और यही इलेक्ट्रॉन जो इसने ब्रोमाइड ने लूज किया है, इट विल गो ऑल द वे ट्रैवलिंग फ्रॉम द एक्सटर्नल सर्किट टूवर्ड्स दिस कैथोड, एंड जब ये इस कैथोड पे जाएगा तो द लेड आयन दैट हैज अटैच्ड इटसेल्फ टू द कैथोड, इट विल गेन द सेम इलेक्ट्रॉन, राइट? तो एसेंशियली हो ये रहा है कि जो 2 इलेक्ट्रॉन्स ब्रोमाइड ने लूज किए हैं, दीज आर द सेम 2 इलेक्ट्रॉन्स दैट लेड हैज गेन. बिकॉज यू मस्ट बी वंडरिंग, ओके ये लूज तो ब्रोमाइड से हुए हैं, बट लाइक वेयर डू दीज इलेक्ट्रॉन्स कम फ्रॉम जो कि lead is gonna gain? These are the same electrons जो कि bromide ने lose किए, right? Hence what happens is, what we established from all of this was कि electrons, okay, let me first establish what an external circuit is. External circuit is one that includes the battery, these wires, and these electrodes. This is called the external circuit, right? And this is called the solution. If we go to the course outline, you'll see that this is exactly what you're supposed to know. The movement of electrons in the external circuit, right? External circuit जिसके अंदर बैटरी वायर्स एंड इलेक्ट्रोड्स आते हैं, उसमें इलेक्ट्रॉन्स की मूवमेंट होती है, राइट. द एनाइन लूजेस दैट इलेक्ट्रॉन, इट ट्रेवल्स ऑल द वे फ्रॉम द एनोड टू द कैथोड, एंड एट द कैथोड द केटाइन गेन्स द सेम इलेक्ट्रॉन. वी सॉ दैट फ्रॉम द इक्वेशंस. द लॉस और गेन ऑफ इलेक्ट्रॉन्स एट द इलेक्ट्रोड्स, दैट्स एग्जैक्टली what's happening. दोनों loss of electrons is oxidation, gain of electrons is reduction. Both of these processes happen at the anode and cathode, जैसे हमने equations बना के देखा. And movement of ions in the electrolyte, that's something you should know. This electrolyte, this liquid part right here, इसके अंदर सिर्फ ions move करते हैं, right? Electrons do not move in this liquid part, right? Electrons move through the all the way from the external circuit from one electrode to the other, right? But iske andar we don't have electrons, iske andar we have ions. And one thing that the examiner can confuse you about, that is a very common question. kabhi bhi ye ion is electrode pe all the way traveling through the external circuit nahi aa sakta. No, these ions will always travel in the electrolyte, right? Aur jo electrons hain, they will travel from the external circuit all the way from one electrode to the other, from anode to the cathode, because anode पे वो electron lose होगा और cathode पे वही electron जाएगा जो कि वहाँ पे बैठा cation उसे gain कर लेगा, right? We saw that from the equations. Okay, so that is something I want you to know. Let me establish this for you. Okay, let's establish that, and here you have it. Okay, so what basically is happening is electrons travel through the external circuit. ठीक है, electrons travel through the external circuit, right? And ions travel through the electrolyte, right? We cannot confuse these two. हम कभी भी ये नहीं कहेंगे कि ions जो हैं वो external circuit से होके हुए जाएंगे जी और electrons जो हैं वो आपके electrolyte में घूम रहे हैं. No, that is never the case. Ions travel through the electrolyte. ठीक है, that is something you should know. This is a very common MCQ question. This is a very common exam trap as well that you need to be able to identify. ठीक है, okay, so that is exactly what's happening. This is at its core जो कि यहाँ पे हो रहा है. Okay, let's talk about what exactly is happening when it comes to why do we choose graphite as an electrode. ठीक है, let's talk about why do we choose graphite as an electrode. ठीक है, let's talk about why graphite. Why do we choose graphite as electrodes? Why graphite as electrodes? आखिर हम graphite ही क्यों लेते हैं electrodes? Why don't we take another metal? हम वो कोई और मेटल क्यों नहीं ले लेते, राइट? हम इन सब केसेस में graphite electrodes ले रहे हैं. This is a graphite electrode. This is all these are graphite electrodes. अब see, electrical conductivity तो metals की भी है, electrical conductivity तो graphite की भी है, but why graphite and why not any other metal? Why not copper, for example? So let's talk about that. Graphite, because the first reason is its high electrical conductivity, right? इसकी electrical conduction ability is really good. So we'll have high electrical conductivity, ठीक है? Or it can conduct electricity, you can say that as well, right? Okay, but this is something that's offered by every other metal as well. हर metal में high electrical conductivity ही है. Why graphite? Because graphite is inert. Graphite is inert. What does inert mean? Inert means unreactive. Graphite does not react, right? हम कोई भी और metal लें, metals are very reactive in general, right? हम अगर यहाँ कोई और metal ले लें which is reactive, when lead ion attaches itself to the electrode, when the bromide ion attaches itself to the electrode, that metal can react with the bromide ion, right? We do know that metals and non-metals react to form ionic bonds, right? So that can very well happen. We don't want that. We just want कि okay, ये bromide ये ब्रोमाइड आयन यहाँ जाए, ये अपना इलेक्ट्रॉन लूज़ करे, वो इलेक्ट्रॉन एक्सटर्नल सर्किट से ट्रैवल करता करता दूसरे इलेक्ट्रोड पे आए और वहाँ पे जो केटाइन है वो उसी इलेक्ट्रॉन को गेन कर ले, राइट? दैट्स ऑल वी वांट. वी डोंट वांट कि ओके यहाँ ब्रोमाइड आयन जाए और ब्रोमाइड आयन इस इलेक्ट्रोड पे जो जिस मेटल का इलेक्ट्रोड बना है उसी के साथ रिएक्ट कर जाए, राइट? वी डू नॉट वांट दैट. सो बिकॉज graphite is chemically inert, that is why we use it. And the third reason is it has a very high melting point. It has a very high melting point, right? How does that how does that exactly help हमारे वाला केस? That helps because जो electrolysis है, जो हमारी electrolysis है, this occurs at a very high temperature. At a high temperature, right? ये जो सारा इलेक्ट्रोलाइसिस का प्रोसेस है, वी कैरी दैट आउट ऑन अ वेरी हाई टेम्परेचर. ओके, सो जब हम इसको हाई टेम्परेचर इन्वायरमेंट में रखेंगे, जब हम इसको बहुत ज़्यादा एक हीटेड इन्वायरमेंट में रखेंगे, तो देयर इज़ अ चांस कि जो इलेक्ट्रोड्स हैं वो मेल्ट कर जाएं, राइट? फॉर एग्जांपल इफ इट हैज़ अ मेल्टिंग पॉइंट ऑफ लेट्स से 100 डिग्री सेल्सियस, राइट? एंड हम उसे एक ऐसे इन्वायरमेंट में रखें विच इज़ 200 डिग्रीज. So obviously its melting point is going to be get exceeded, it's going to melt and it's going to dissolve into the electrolyte itself, right? We do not want that. Because it has a high temperature, हम कोई ऐसा इलेक्ट्रोड यूज़ करते हैं जिसका मेल्टिंग पॉइंट इवन इस टेम्परेचर से भी हाई हो, so that electrode cannot melt, right? That is why these are the three reasons why we use graphite as your electrodes, right? That's why we use graphite as your electrodes. Let's talk about another molten compound key example, and that is something that is going to really help you when it comes to identifying what do we do. Okay, acha ji, that is going to really help you understand fundamentally कि okay molten compounds की half equations हमने किस तरह से लिखनी है, and that is something that is very crucial. अच्छा जी. Okay, let's talk about what compound should we talk about. Let's talk about sodium chloride, right? Let's talk about sodium chloride. Electrolysis of molten sodium chloride, molten NaCl, ठीक है? And again we'll use inert electrodes made of graphite, right? Inert electrodes. There is a case in your O-level syllabus which includes an electrode that is reactive, but that comes when we'll discuss when we discuss the industrial application of electrolysis. You don't have to worry about that right now. अच्छा जी, अगर हम molten NaCl ले रहे हैं जी, if we're taking molten NaCl, what do you think will be the cations and the anions in this solution? Cations और anions कौन से होंगे, right? Do let me know that. Okay, so we'll have a Na positive ka ion, right? We have a sodium cation and we'll have a chloride anion, sodium cation, right? Tons of these ions present in the electrolyte. Achha ji. So okay, again we'll see okay, the positive electrode is the anode. This is the anode. इस पे anion जाएगा because it's positive. It will attract the negative charge, unlike charges attract, तो positive पे negative charged ion जाएगा, and that is chlorine. That clearly is chlorine. So chloride ion is going to go to the positive electrode, and on the negative electrode will have the sodium ion go, right? Okay, let's write the equation. Let's talk about the anode. Anode पे क्या हो रहा है? Anode पे we have chloride ion going. Let's write its initial and final states. Initial and final forms. The initial form is chloride. What's going to be the final form? The final form is going to be Cl2, right? Again, it's a halogen, just like bromine. It exists as a diatomic molecule. Okay, let's balance the number of particles. We have two chlorine atoms here. We'll have two chloride ions here. Okay, let's balance the charges now. We have -2 ka charge on the right side. In order for it to be balanced, we'll release 2 electrons from this whole system, like 1 electron from each chloride atoms. What's happening is we have this is 1 chloride ion, right? This पे negative charge है, and this is अनदर क्लोराइड आयन जिस पे नेगेटिव चार्ज है, इन दोनों पे नेगेटिव चार्ज है। अब ये जो दो इलेक्ट्रॉन्स इसने लूज़ किए हैं, इसने अपना एक लूज़ किया है और इसने अपना एक लूज़ किया है, एंड दीज टू इलेक्ट्रॉन्स आर द वंस दैट आर बीइंग लॉस्ट, यू नो। दोनों क्लोराइड आयंस में से दोनों एक एक लूज़ करते हैं, एंड इन टर्न दैट इज 2 इलेक्ट्रॉन्स। ओके, नाउ व्हाट हैपेंस इज क्लोराइड आयन इधर गया, इसने इलेक्ट्रॉन्स लूज़ किए, दिस इलेक्ट्रॉन विल अटैच इटसेल्फ हियर, इट विल ट्रैवल ऑल द वे फ्रॉम द एक्सटर्नल सर्किट, इट विल गो टू द नेगेटिव इलेक्ट्रोड, इट विल गो टू द नेगेटिव इलेक्ट्रोड विच इज ऑल्सो कॉल्ड द कैथोड, जहाँ पे केटायन ऑलरेडी सोडियम का है और उसी ने वो इलेक्ट्रॉन्स को गेन करना है, राइट, उसी ने वो इलेक्ट्रॉन्स को गेन करना है। सो लेट्स टॉक अबाउट द कैथोड, लेट्स टॉक अबाउट द कैथोड की इक्वेशन, right? Let's talk about the cathode key equation. We'll have the initial form of the element, we'll have the final form of the element. Do we write 2 or 3 or any subscript here? No, because it's a metal, it exists as a monoatomic atom. We have both atoms balanced here, dono sides pe we have one particle, and in order to balance this charge we add how many electrons? This has a +1 ka charge, so we'll add only 1 electron, and there you have it, you have this balance, ठीक है, you have this balance. अच्छा, what if I tell you the concept of net equations? Let's talk about the concepts of net equations, right? अब these are half equations, right? In a chemical reaction आप हमेशा देखते हो कि products और reactants multiple होते हैं, and we have a proper equation which shows what's happening at the reaction as a whole. But इस case में we only show this is आधी कहानी, this is half of the story, this is the second half of the story. In total क्या हो रहा है? In total क्या हो रहा है, right? Okay. So in order to write the net equation, the first step, this is also something that's going to be, right, हम इसको steps में देखेंगे. Okay, the first steps is we'll see that the number of electrons in both half equations is the same or not, right? Okay, so इसके अंदर we have 2 electrons and इसके अंदर we have 1 electron, right? The number of electrons in both half equations is not the same, you know, so it's not the same. Check if number of electrons is same in both half equations, right? It has to be same. अगर ये same नहीं है तो what do we do then? If not, तो what we do is कि हम इसी इक्वेशन को किसी ऐसे नंबर से मल्टीप्लाई करते हैं एज अ होल कि इसमें नंबर ऑफ इलेक्ट्रॉन सेम हो जाए, राइट? अब इसमें एक इलेक्ट्रॉन्स है एंड वी वांट टू मेक इट टू 2 इलेक्ट्रॉन्स. व्हाट शुड वी डू? दैट इज एब्सोल्युटली करेक्ट. वी मल्टीप्लाई दिस होल इक्वेशन बाय 2. हम पूरी इक्वेशन को 2 से मल्टीप्लाई कर देंगे. ओके, सो 2 मल्टीप्लाइज विद सोडियम का आयन विच फॉर्म्स 2 sodium ions, right? And 2 multiplies with an electron and that becomes 2 electrons, and then this 2 also multiplies by this sodium atom and it becomes 2 sodium atoms, right? Okay, so now what happens is we have this equation and we have this equation. अब इसके अंदर भी 2 electrons थे, इसके अंदर भी 2 electrons थे, right? Now the number of electrons are balanced. Once the number of electrons are balanced, what we do is okay, we combine both equations. How do we combine both equations? इनको combine किस तरह से करेंगे? We combine both equations, and how we necessarily do that is let me copy this for you so that it makes a lot of sense. This is the cathode key equation and this is the anode wali equation. This is how it is. Okay, let me put it there. अच्छा जी, अब how do we combine this? We actually combine this equation. What we do is कि हम जो reactants हैं दोनों में जो left side वाली चीज़ें हम इनको combine करेंगे और दोनों equations में जो right पे जो भी we have entities, whatever entities we have on the right side, हम उनको combine करेंगे, right? So we essentially combine the products on the right side, we combine the reactants on the left side, right? And what happens is as a result, what happens is, okay, so 2Na plus 2 electrons plus 2 chloride ions, and that is going to form, okay, let's combine these 3 there. We have 2 sodium atoms, we have a chlorine molecule, and we have 2 electrons. Okay, so what essentially happens is you see these 2 electrons are cancelled on either side. How exactly? Because यहाँ 2 electrons add हो रहे हैं. If we mathematically take it to the other side of the equation, it's going to get subtracted, and 2 plus 2 minus 2 is always going to be 0. तो basically हम इसको either side of the equation पे कट कर देते हैं, right? And you see that is the reason जिसकी वजह से हम number of electrons balance करते हैं. अगर यहाँ 2 हो और यहाँ 1 हो तो you'll never be able to cancel these electrons out. And you do know we have done a lot of full equations in the past. उसके अंदर कभी भी आपको electrons नहीं दिखते, आपको बस एक you just see a whole story where you see okay which elements and which atoms combine or break down to form what exactly. You never see this term in a full equation, right? And that is exactly what we're doing here. So what ends up happening is कि इसकी final net equation is going to be 2 sodium ions plus 2 chloride ions, and that is going to convert into, that is what's happening. You can absolutely see कि यहाँ पर in this equation we have number of atoms balanced. We have 2 chlorine atoms here, we have 2 chloride ions here, we have 2 sodium atoms here, and we have 2 sodium ions here, and hence this is how you write the full equation, right? So let's revisit the steps. The first step is going to be check if the number of electrons is same in both half equations. If it is, you don't need to do this step. आपको multiply करने की ज़रूरत नहीं, you just jump into step 2. And step 2, you see, you combine both equations. And how do you combine exactly? You combine the reactants together, and you combine the products together, and you write it like this, and then you just cancel the number of electrons, and hence you have a final full equation. So that is also something that you can be tested on in the examination, right? Okay, so the next thing that we're going to talk about is what are we going to talk about? We're going to talk about aqueous compounds, right? We're going to talk about aqueous compounds. We talked about how we were going to deal with molten compounds. We did discuss this example. We discussed another example of molten sodium chloride, but let's talk about aqueous sodium chloride now. We talk about it in its dilute form, and we talk about it in its aqueous form as well. That's something we should be discussing now.